Hello everyone. So today we are going to discussing charge of an electron by Millikan's oil drop method. So firstly, what is this Millikan's oil drop method? So did the Millikan do? So Millikan experimentally determined the charge of an electron. This is what the Millikan's oil drop method is. And how it is going to happen? So here this is the structure or the experimental setup of the Millikan's oil drop method. So, the apparatus consists of two optically plane parallel brass plates A and B. So, here we can see the A and B are the two optically planed and they are the brass metals. In A plate there is a small hole is made because to get the oil drops into the apparatus, right? The lower plate is earthed and the upper plate is connected to positive potential of the order 10,000 volts high tension battery. And this observation chamber is situated in a bigger chamber C, which is completely surrounded by a constant temperature oil bath E. You can see here. Next, this is the experimental setup. Next, we shall discuss how it is going to happen. The tiny drops of heavy non-volatile oil are sprayed into the chamber by atomizer D. This is the atomizer D. The tiny oil drop methods are sprayed into this small hole to pass through this from the atomizer. And few oil drops enter the space between the plates through the pinhole edge in the top plate A, as I showed. These drops are charged due to the frictional effect at the atomizer top. Means in the atomizer top of the atomizer we have the frictional force. Due to that frictional force, some of the oil drops get charged. The air between the plates can be ionized by allowing X-rays to pass through it. So what happened next is the plates, the air that is present in the plates are ionized by passing the X-rays. Then the drops may pick up additional charge along with their before they got some charges, along with passing the X-rays they get additional charges. The drops are illuminated by the light from the arc lamps. The oil drop is observed by means of short focus telescope T provided with the millimeter scale in the eyepiece. So this whole observation is recording in the millimeter scale by the eyepiece. The plates are first connected together so that the electric field between them is 0. So there is no electric field is applied here. The plates are connected together. So the single drop is observed in that case. When there is no electric field, he observed the single drop through the microscope as it descends under the action of gravity. A, as the drop is moving in the viscous medium, means the air present in that, right? There is no medium, there is no electric field. Under it is descending, the drop is descending under the air medium, so it will have the constant terminal velocity. We know that the Stokes theorem, what says that it gravitational force equals to the viscous force. What do you mean by the gravitational force? mg is equal to 6 by eta rv. So call this equation as a 1. mg, mass, we know the mass of the that we have that mass of the sphere, right? Mass of the sphere means the mass of the oil drop. 4 pi 3 pi r cube rho minus sigma, these are the densities, and into the G. In the place of m, we have the effective mass of the oil drop is m is equal to 4 by 3 pi r cube rho minus sigma. We are substituting here, and G kept as it is, equal to 6 pi eta rv. Here we know density equals mass by volume. So mass equals density into the volume. So this is what we have calculated, the volume into the density. What we have, the mass. And one r and another r get cancelled, r square we left with, and rearranging the terms, 6 pi eta v and 1 pi get cancels, this goes to here into g, 3 by 4, and cancelling out we get 9 eta v divided by 2 rho minus sigma into g power 1 by 2. So m is the effective mass of the oil. We have to put, substituting the value of a, we get m is equal to, we have the r, right? We have to substitute the value of this here, 4 by 3 pi 9 eta v divided by 2 rho minus sigma into g power 3 by 2 into the rho minus sigma. We just substituting here, it becomes 3 by 2. So 1 rho minus sigma get cancelled, equation number 2. Thus by measuring the V, the effective mass of the chosen oil drop can be calculated. Now an electric field of is applied steadily. So this is the concept is when no electric field is applied. This, when electric field is applied, what is going to be happen, we will study next. Apply steadily so that the drop moves upwards. So what happens when the electric field is applied, the drop started moving upwards. In evacuated tube, there is no medium, right? Started moving upwards. Here it is descending, but here it is going ascending with steady velocity u1. So if the total charge of the drop is n1e, now let the total charge of the drop is n1e, then the resultant upward force on the drop is E1e minus mg. So next, according to Stokes' law, we have that E1e minus mg equals 6 pi eta r v1. The force is equal to viscous force. So E1e minus mg is equal to 6 pi eta r v1, equation number 3. So we have to divide equation number 3 by equation number 1. What we have, the equation number 1? Equation number 1 we have this mg is equal to 6 pi eta r v1. So we are going to divide this by the equation number 3. So E1e divided by mg 6 pi eta r v1 by 6 pi eta rv. So we have to cancel it. We left with E1e divided by mg minus 1 is equal to v1 by v2. This becomes E1e by mg v1 by v plus 1. We calculated the En1e, total charge, the charge of an electron, total charge of an electron we calculated it. Call this equation number 4. Now the air between the plates is irradiated with X-rays. We discussed here the air between the plates is the drops get more additional charge due to the passing through the X-rays. So we are going to studying here right now. X-rays ionizes the air molecules. Oil drops under observation may pick up one or more ionic charges. We discussed in the experimental setup, working of the experimental setup. Due to acquisition of charges, the velocity of drop changes suddenly. When E is constant, let the new velocity of the drop be V2, corresponding charge on the drop is N2E. What we pass the X-rays, the charges get additional charges due to acquisition of charges. Velocities of drops get charges also became varies and the velocity became also varies. The velocity v is v2 and charge on the drop is n2e. So n2e, similarly we are going to do this. Mg v2 plus v1 divided by ev. V is as is the same.